Hello, hello. Hello, am I audible and is my screen visible? Can anyone please let me know?
Yes, sir.
Okay, thank you. Hello everyone, welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this live session is for week 12. In week 12, mainly computational learning theory and some topics in reinforcement learning were covered. So we will solve some practice problems on these topics. And if there are any doubts regarding these topics, you can ask me during this session. So we will start solving some practice problems first. So this is the first question. Generalization error is given by this expression that epsilon h is equal to probability of hx not equal to y, xy drawn from capital D. So what is this D that is used in this expression for generalization error? So that is the question. What is D? Options are the underlying distribution we are trying to estimate, a sample of the underlying distribution, a different distribution that we are using to estimate the true underlying distribution, and the last option is the universe of distributions. So you can write your answers in the chat. So the D here is the underlying distribution that we are trying to estimate. So basically we are trying to predict y from x. So uh, we can say that we are trying to basically uh, sample these xy points from some distribution D. So we are trying to basically trying to find out the underlying distribution D from where these xy points are sampled. So the D is the underlying distribution that we are trying to estimate using our hypothesis H. So that is the correct answer. A, option A is the correct answer. Now question 2. The hypothesis function obtained by empirical risk minimization is denoted as h hat x is equal to r main of epsilon h. H belongs to capital H. So capital H is the uh, hypothesis class, and H is one hypothesis from the hypothesis class. And in empirical risk minimization, what we try to do is that we try to find out the hypothesis H hat, which has the least empirical risk or least empirical error epsilon H. So if this capital H is a class of neural networks in this expression, which aspects constitute its space? So H is the hypothesis class, and if the hypothesis class is the class of all neural networks, then which aspects constitute its space? Option A is different number of layers, option B different number of neurons per layer, option C different values for weights, option D different inputs. H is the hypothesis class, um, and if in our case we consider H as the as a class of neural networks, then which aspects constitute its space? Different number of layers, different number of neurons per layer, different values for weights, different inputs. What constitute the uh, class of neural networks for a given hypothesis? So if H is the class of neural network hypothesis, then it would contain uh, such infinite number of hypothesis functions. So H1, H2, each of these hypothesis functions is a neural network with different values for their weights. So once we have fixed the architecture or structure of the neural network, now when we train, we basically update the values of the neural networks. We are basically searching over a space of um, values for the weights. So different hypotheses in this hypothesis class would be different neural networks with different values for the weights. So correct answer would be option C. So different values for weights is the aspect that constitute this space, which is the capital H, which is the hypothesis class capital H. Now question 3. As discussed in the lecture, most of the classifiers minimize the empirical risk, basically the empirical error it minimizes. Which of the following is an exceptional case? Option A is perceptron learning algorithm. Option B is artificial neural network. Option C is support vector machines. Option D is both A and B. Option E is none of the above. So which of the following um, Machine learning algorithms do not exactly minimize the empirical risk directly. Ansela Rian says option A, and Karanath says option E, none of the other. So out of these algorithms mentioned, support vector machine. So this method maximizes the margin. So margin is basically the distance between the distance of the learning curve or the distance of the decision boundary from the closest point. So it tries to maximize the margin. It does not directly try to minimize the empirical risk or some error value, for example, mean squared error or the logistic error. It does not try to minimize such empirical error functions. Rather, it tries to maximize the margin, and by maximizing the margin, it is able to classify the data points, but it does not directly minimize the empirical risk. Whereas the other methods like perceptron learning algorithm, there the empirical error, that error function that it uses, is basically the number of misclassified points. It tries to classify the points perfectly. That is the objective in perceptron learning. So number of misclassified points is the error function in case of perceptron. In case of neural networks, um, they in most of the cases they use cross entropy loss function, which is one sort of empirical error function. But in support vector machine, it uses it uses the objective function, where the objective is to maximize the margin. So that's why option C is the correct answer. The other two methods use some form of empirical risk or error, and it minimizes that empirical risk to find out the best classifier, but it is not the case in case of SGM. Now question D, question 4. What happens when your model complexity, such as interaction terms in linear regression, order of polynomials in case of SVMs, increase? So what happens when your model complexity increases? Options are: model bias increases, option B, Model bias decreases. Option C, variance of the model increases. Option D, variance of the model decreases. And now we're going versus option C, which is variance of the model increases. Okay. And multiple options may be correct in this question. Aishwarya Shekhar says B and C. There is model bias decreases and variance of the model increases. Okay. Anyone else? Aishwarya says bias decreases. And Taranath says B and C. Okay. So the correct answers are model bias decreases and variance of the model increases. So if you increase the complexity of your model, so the bias is basically the difference between the correct output and your predicted output. So if the model complexity increases, so your this bias error would come down, so it would decrease. But the variance, which is basically the sensitivity of the output of your model, would increase. So as complexity increases, if you change the value of the input slightly, the output changes drastically for your model, which is also not desirable. So even though the bias error decreases, variance error would increase if you increase the complexity of your model. So there are two correct answers. Option B, model bias decreases. Option C, variance increases. Now question 5. Aliens challenge you to a complex game that no human has seen before. They give you time to learn the game and develop strategies before the final showdown. You choose to use machine learning because an intelligent machine is your only hope. Which machine learning paradigm should you choose for this? Supervised learning, unsupervised learning, reinforcement learning, use a random number generator and hope for the best. Antaranath says option C, Anagha Chowgankar says option C, Aishwarya Sekhar says option C. Okay. Anyone else? Shweta Lakshmi says option C. Okay. So the correct answer is option C, reinforcement learning. So if you have to play a complex game that you have not seen before, so you don't have labeled data points with you, so that you can train your model in supervised manner. So supervised learning you can't do, and unsupervised learning is not suitable for game playing because basically for some input you have to take some action. So actions are basically the output levels or class levels. So you need to have a class variable. So unsupervised learning is also not possible. And reinforcement learning is the most suited machine learning paradigm for such tasks because you have not seen this game before. So first you have to play the game episodically, and trial and error method has to be used. So you start playing the game and you make some errors. Based on that, you tune your parameters so that you learn better how to make better strategies to win in that game. And which is what happens in reinforcement learning, that the agent tries to explore the environment based on the rewards that it gets, and rewards are given based on the actions that it takes. So based on those reward or penalty values, it is able to learn how to maximize its total cumulative reward while playing the game. So reinforcement learning is the best suited paradigm to use in such a task. Now question 6. In the Pavlov's dog experiment, what is the input signal to the dog and what is the reward? So options are bell and digestion. Option B is food and praise. Option C, food and digestion. Option D is bail and food. So it's Lakshmi says option D, which is bail and food. Ansela IBM says option D. Asperius Sekhar says option D. Ananga Sodhankar says option D. Okay. So correct answer is option D. So bail is the input signal to the dog, and whenever the bail is used, so reward in the form of food comes. So food is the reward and bail is the input signal. Now question 7. Which of the following measure best analyze the performance of a classifier? Option A, precision. Option B, recall. Option C, accuracy. Option D, time complexity. Option E, depends on the application. Shweta Lakshman says option C, which is accuracy. Aishwarya Sekhar says C and D, accuracy and depends on the application. Option Nagachugankar says option E, which is depends on the application. Ansela Dion says option depends on the application. Anyone else?
Sir,
Yes.
sir, option B, C and A.
Okay. On the says A, B, C, and D. So the correct answer would be E, that it depends on the application. We cannot say which measure would be best suited for a classifier for a specific task. So it completely depends on the task that that classifier is handling. It might be, I mean, accuracy is the most used measure, but in if the data is balanced, then accuracy might be um, the best measure to analyze the performance of the classifier. But if the data set has class imbalance in it, then accuracy is not really a good measure. Then even if the classifier uh, is really bad, it still can get 99% accuracy if there is a class imbalance in the uh, test data set. Uh, in those cases, precision, recall, F1 score, these measures would be better suited. And in many medical applications, we see that recall is highly used because we want to minimize the true negatives. So in those cases, recall is used. In some applications, precision might be used if we want to uh, maximize the true positive rate. So in different applications, different measures can be used. So it completely depends on the application or the task. Now, question 8: which type of feedback does an agent in reinforcement learning receive?
Sir, D. Option D, rewards or penalties.
Okay, you can write your answer in the chat. Option A, predictions. Option B, levels. Option C, clusters. Option D, rewards or penalties. So as per as request D, ancillary answers D, another two answers D, Nitaran answers D, Muthukumaran ISS D, speculation says D. And so the correct answer is option D, rewards or penalties. That is the feedback that the agent gets from the environment in reinforcement learning. So it at a hello, am I audible? Hello.
Yes, sir, you are audible.
Okay, I lost my internet connection for a while. Okay, now it's back. So in reinforcement learning, the agent at a given state takes some action. Based on that action, the agent receives some reward or penalty from the environment. So that is the feedback that it gets from the environment. So D, option D is the correct answer. Now question 9: you are designing a reinforcement learning agent for a racing game. Among the following reward schemes, which one leads to the best performance of the agent? So it is a racing game. So option A is +5 for reaching the finish line, -1 for going off the road, +5 for reaching the finish line, minus 0.1 for every second that passes before the agent reaches the final line. Option C says +5 for reaching the finish line, minus 0.1 for every second that passes before the agent reaches the finish line, and +1 for the agent uh, for going off the road. Option D is -5 for reaching the finish line, plus 0.1 for every second that passes before the agent reaches the finish line. So which reward scheme would lead to the best performance of the of a racing agent? Muthukumaran IR says option B. Sweta Lakshmi says option A. And Antarana says option B. Anaga Jogan says option B. Aishwarya Sekhar says A and B. Anyone else? Any other answers? So the next one says A and B. Anyone else? So in a racing game, there are mainly two objectives. First is that we want to complete the race or finish the race basically. And second one is to finish it as fast as possible, so time minimization. So completing the race and time minimization, these are the two objectives that we have in a racing agent. So if it completes, it should get a high reward. And for time minimization, uh, so in every step or in every second, we can give the agent some small negative reward or penalty so that it does not waste time during the race. So these two can be achieved by this option B, that a high reward of +5 would be given for reaching the finish line, and this penalty of -0.1 for every second that passes before the agent reaches the finish line. So this penalty ensures that it would learn to complete the race as fast as possible, as it gains more and more experience by playing the game episodically. And for finishing the line, it has to get a high reward. And we might give a negative reward for going off the road, or we might also terminate the uh, game when it goes off road. So that's why option A might not give you the best result, because option A does not give any penalty for each second or each time step. We need to give it a penalty, small penalty for every time step that it consumes during the race, so that it learns to complete the race as fast as possible. And so for going off the road, we might not give any reward, simply terminate the process, terminate the game. So in the process, it would learn that it should not go off the road. It should stay within the road and finish the line to have a higher reward. So that's why option B is the correct answer. Option A is also ensures that it will be able to finish the line, but option A does not ensure that it will um, minimize the total time taken to complete the race. So option A is the correct answer. Now question 10. You want to create a self-driving car software in the context of the standard reinforcement learning framework. What would you classify as the state and actions? And note that your system does not have access to previous states, which is the assumption that is there in Markov decision process, that you don't need to remember your previous states. So what would be the state and what would be the action in case of self-driving cars? So option A says that state should contain current steering wheel position, current pedal position, current speed. Action should be turn the steering wheel, press the pedal. Option B says state should contain current steering wheel position, current pedal position, current acceleration, and action should contain turn the steering wheel, press the pedal. Option C says state should contain current steering wheel position, pedal position and current speed. Action should be change direction, change speed. And option D says current state should contain current steering wheel position, current pedal position, current acceleration, and action should contain change direction, change speed. So, what should be the state of the agent and what should be the action of the agent? So, the reference is option A. And the answer is A and B. Answer B answer is option A. Okay. Anyone else? So, state should contain all the information required to make a decision or to take actions basically. All the important informations it should contain. So the important informations should include in case of a self-driving car is that what is the position of the wheel, in which way it is turned. So we need to know that so that we can turn the steering wheel accordingly. And what is the position of the pedals? All the pedals, including the accelerator, all three pedals. It should know the positions of all three pedals basically, so that it can take actions based on the positions of those pedals. And the third thing that it should know is the speed of the vehicle. Based on that, it would decide, the agent can decide whether it should accelerate or decelerate. So current speed is the third information that the state should contain. And actions are much easier because there are two types of actions in case of car driving. First is the um, turning the steering wheel. So that is the first kind of action. So it changes the direction of the car. And second one is pressing the pedals. There are three pedals. So pressing the pedals is also um, some kind of action that the agent has to take. So these are the two things that the action should contain: turning the steering wheel and pressing the pedals. So option A is the correct answer, that state should contain steering wheel position, pedal positions, and speed. So option B says that it should contain current acceleration, but current acceleration is not really required as an information in state space, because uh, we just need to know the speed of the vehicle, and based on that we can control the speed using the pedals. So current speed is very necessary in the state space, but current acceleration you might keep, but it is not as necessary as speed, because with using the value of the current speed, you may decide whether you want to accelerate or decelerate, but using the value of current acceleration, you don't know whether you should decelerate or accelerate. So option B is not the correct answer. Option A is the correct answer. Now question 11. Which of these classifiers do not require any additional modifications to use them when we have more than two classes? Yes.
Option D.
So options are decision trees, linear classifiers, uh, support vector machines, and k nearest neighbors. And more than one option may be correct in this question. So which classifier do not need any additional modifications even if we have more than two classes in our dataset? Muthukumaran Iyer says D and C. Um, Sweta Lakshmi says A, C, D. Asperia Sekhar says A and D. Sweta Lakshmi says A and D only. Pradina More says A, C, D. Anagasa Ugamkar says B, C. Ansela Game says A, D. Okay. So correct answers are decision trees and k nearest neighbors. So in decision trees, we don't need any additional modifications except that if you have three classes, so uh, every leaf, the leaf of the decision tree contains the class. So you don't need to modify anything in decision trees. Even if you have more than two classes, any number of classes it might have, the leaf would contain the class. So it does not require any specific modifications for multi-class classifications. Linear classifiers are linear classifiers need a lot of modifications. Even instead of two classes, if you have three, four classes, so output nodes should have three or four nodes in that case, and the error function would also change based on the number of classes you have. So you need a lot of modifications for linear classifier. And support vector machines, in general, support vector machines in its naive form only supports two class classification problems. So if you want to classify three classes, then you need more than one linear boundaries in software support vector machines. So for three classes, you need such structures where this would contain one class, this would contain another class, this would contain the third class. So SVM requires a lot of modifications for more than two classes, and k nearest neighbors do not need any modification. It simply computes the k nearest neighbors of a given test point, and the class with the majority would be the class of the test data point. So it doesn't need any modifications. So A and D needs no modifications for multi-class classification. The other two needs a lot of classification, a lot of modifications for more than two classes. So option A and D are the two correct answers. So these were the questions that I wanted to discuss in this fixed live session. Now, if there are any other questions or queries, you can ask me.
Sir, excuse me, sir.
Yes.
Sir, in the week 12, for the three videos they are given in the brackets optional, what is the meaning of that one, sir?
Optional, I'm also not sure. It may be that questions might not come from those lectures in the final exam, but I'm not sure why it mentions optional. You can post your question in the discussion forum. Only the instructor would be able to tell you whether it what it means. Is there any other questions or queries?
So can you recommend any book, specific book for learning all these algorithms?
Two books are already referred in the course homepage, I
Sir,
think. Uh,
Yes, one book is also there by the sir who is teaching us this course, but that is unable to download.
sir,
Unable to, yeah, in that case, you have to find some way to get that book either from
sir,
library or somewhere. But the two books referred,
Oh,
most of the algorithms taught are from
okay,
those two
okay,
books.
okay.
sir,
Yes,
Okay, fine, fine. Thank you, sir.
sir,
yes.
sir. Any handwritten notes is available for this tutorial, or the questions which we have discussed in the lectures that will come in the exam? Any guesses, sir?
Handwritten lecture notes from the video lectures.
Yes, sir.
Yeah, everything taught in the video lectures should be included in the syllabus for the exam. So uh, you have to read everything that is taught in the video lectures.
Sir, any handwritten book notes is available, sir, for
I
this?
don't know any such handwritten notes.
Okay, sir. Thank you, sir.
Okay. If there are no other questions or queries, we can end this live
Uh,
session. Okay.
just one actually.
Sir,
Yes. Yeah. One of you go first. Muthu Kumaran Nair, do you
sir.
have any doubt?
Yes, sir. I am having a doubt. Sir, in the previous question which they are asking in the machine learning, that also we need to refer, or we have to refer only the latest one?
Previous one means
Previous questions which was come in the machine learning that time exams, it must happen that the repeated questions may come in the say, in that paper which we will appear now
yeah,
in the
but
afternoon
how would
session.
you access previous year's questions? You don't have
No,
access.
sir, but while solving that questions in the practice, like a mock exam in our system at home, so it gives us some confidence. That's why I'm having the doubt to ask.
I didn't understand your doubt properly.
Sir, the questions which they are asked in the previous years regarding that machine learning course,
Yeah,
which we are
but
studying right now.
how would you get those previous year's questions? The previous year questions are never released by NPTEL.
Okay, sir. Okay, sir.
Also, one doubt.
Yes.
Actually, what is the meaning of expectation of y given x? What is the
Thank you,
meaning?
sir.
Uh, Expectation of,
Y given x. What is the meaning?
so expectation of y, so it should be like this. Y given x is basically you are taking the expectation of y, probability of y given x dx, if it is a continuous distribution, and if it is a discrete distribution it would be something like this. So here what is the expected value of the variable y, that's why y appears here, but the probability distribution is probability of y given x, from where you
When
are
we
sampling the
uh,
y
when
value.
we make when we make an assumption that the expectation of y given x is linear, what
Hmm.
does it imply?
Expectation of y given x is linear.
Yeah. Yes.
Okay, linear means it's simply expectation of y given x, so uh, y given x is linear. I'm not able to understand it properly. What
No,
do you?
actually, I saw somewhere that there's an assumption that expectation of y given x is linear. Why? I mean, what does it? What is the implication of that? Not in all cases. In some cases, I saw like that. I just wanted to get to know what the meaning of that assumption is.
No, so this is the expression expectation of y given x is basically the expected value of this random variable y given some value of x. So it should be a constant. So I don't understand how can it be linear. It may be specific to that question.
Okay,
Otherwise,
okay,
without the
okay.
context,
I
I'm
have
not
not
able to
noted.
understand it
I
properly.
have not noted the full question. So at this point alone, I did not understand. That's why I had noted.
So
Okay.
this generally the expectation is basically one value, the expected value of y given some value of x. So that would
No,
be a
can it
scalar
be
value, but
linear? Can that value be linear in x or something? Or can
yeah,
that
that
linear?
might be possible. That linear in x in the sense a into x, a is some constant. So say x equals to some small x. So this, yeah, it might be like this, that it is
So
equal
in
to
which
a into
case,
x.
could you give an example just to understand what in which context it will happen like this?
No, I mean it is really difficult to find out in which probability distribution it would appear.
Yeah, that's what. Just wanted to understand what is the meaning of that. I
You
mean,
know,
when
it
it
is yeah, it is difficult to find out in which probability distribution it might appear. It is not that easy
or
to.
it can be linear with respect to y also, or
No,
with
not
respect to
y, because we are trying to find out the expected value of this variable y. So it would
mm.
be one value that might depend on the x,
X.
variable
Okay.
x, but
Mm-hmm.
it should not depend on y because we are trying to find out the expected value of y only.
Okay. Okay.
But it
And
is not possible to understand in which probability distribution it might appear. For some probability distribution it would appear obviously, but it
okay.
is not easy to understand from which probability distribution this linear a into x might appear.
Okay. Another doubt is actually for that what do you call that initial that linear what do you call it when we are solving a system of linear like that is there, no? So we will be having y root sum square we'll be taking for sigma y I minus f of xi, no? You that when
In which topic? Can you repeat your question from the
that
beginning?
is the what do you call the what do you call that linear classification very
Hmm.
that initial
Yes.
linear
I think that is in
classification.
linear regression. Linear
Yes.
regression you are talking about.
Linear regression,
Yes.
exactly.
Yes.
Yes.
So there
Okay.
we will be taking y minus x into y minus f of x we will be taking, no?
Y minus f of x. Yes, that is the
That
but
we'll be taking, yeah, but that for finding out the root sum square, we'll be squaring that also.
yeah.
But actually, the doubt is that y minus f of x we can write as y minus x into beta. That is actually
Yes.
in the
Yes.
lecture
Yes.
also it is given
Hmm.
like that.
Hmm.
Y minus x beta,
Hmm.
the whole transpose into y
Yes.
minus x beta.
Hmm. Hmm.
So in that expression, when
Hmm.
we take the dou by dou beta of RSS, we will be getting one expression that
Hmm.
is okay. But when we take dou squared RSS of beta by dou beta, whatever was shown in that lecture, I did not understand how that sign was coming. Shall I tell you the value for this? Can you? I think if you write once, it will be easy.
So it
It is
is y minus x beta transpose y
ah
minus x beta. This is
yeah.
the
So we have to
uh,
differentiate it with respect to beta two times.
yes.
So can you show that part alone?
Okay, let me first recall what was the differential. So, for
It is
example, if in
yeah, the
any
differential is y
so
minus x beta into
so
2 into x transpose.
y minus x beta into
X
2 into
transpose.
x transpose, it would be here it would be x transpose, or x transpose would be here.
I think in the front only. 2x transpose into y minus x beta. Correct.
Yes,
Sorry.
yeah, yes, I think it might be the yes.
Now, when you differentiate it once more, what will we get with respect to beta? Can you please tell me?
Yeah, if we
But it will be minus.
different
Okay, actually, here also there's a minus sign. Minus 2x.
the if we expand it, so it would be something like this.
No, actually, one more doubt. Actually, in this expression, there is a
Hmm.
minus 2x transpose. It is not simply there is a minus 2 also.
Yeah,
Because x is.
minus 2 comes because you have this minus in front
Yeah,
of it.
can you put that minus also?
Yes.
Okay. Now,
So
now
if
can
you
you tell me?
expand it, it would
Now,
become this. If you
uh,
take the derivative once more, the first term for the first term derivative with respect to beta would be 0,
okay.
and for the second term it would simply be x transpose x, because this beta would disappear because you are taking derivative with respect to beta.
Okay, okay.
So it should be 2 x transpose x, I think.
Okay, okay. Thanks.
Yeah.
Thank you.
There are no other doubts, then we can end this live session now. Also, tomorrow I will have one more extra session where I will discuss some questions from all the uh,
But tomorrow, one
topics.
more TS class is there, no? That you
Yeah,
are taking that.
that is the fixed class. Every week it happens, and I will have one extra session from 7 to 8. That is
So
for
she
only
she
1 hour.
may take till 8 actually. 6 to 8 she will be there usually.
Yeah,
So can
yes.
you please
No, I mean it is an extra session. Like she cannot change her time because that is a
can you
fixed time
take
slot
from
for her.
8 o'clock or something then?
I've already scheduled it from before, so I cannot. I mean, initially I scheduled it for Wednesday, but I have a seminar on Wednesday, so I have to prepone it to Tuesday. So those of you who will join the other session, you may join. That is not a problem because all these sessions would be recorded, so that is not a problem.
Okay. Okay.
And also, if that session is over early, then you may join from 7 p.m. My session is from 7 p.m. to 8 p.m.
And what is the topic that you will be covering tomorrow?
I will discuss some questions from all the topics, maybe one
Okay.
question from each week, something like that.
Okay.
Okay, so thank you everyone for joining.
Thank you.
Thank you, sir.
Thank